Friends, welcome to the class. Today we'll discuss about some of the first n terms of an AP. It says in an AP, if A is the first term and the common difference is D, then the sum of the n terms is given by the formula Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. The formula can also be written as Sn equals to n by 2 whole into a plus an, where an is the nth term of an AP. If L is the last term of AP of n terms, then an equals to L. So we can write the sum of the n terms of an AP as Sn equals to n by 2 whole into a plus L. Let's see an example. Find the sum of 15 terms of AP 3, 7, 11, 15 and so on. The given AP series is 3, 7, 11, 15. Here A is 3, D is 7 minus 3 or 11 minus 7, which is equals to 4, and N is 15. Now the sum of n terms is given by the formula Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. So if we put the respective values of a, n, d, then definitely we can get the sum of the 15 terms. Let's check it. So the sum of 15 terms is denoted as S15 equals to 15 by 2 into 2 into 3 plus 15 minus 1 whole into 4. So on solving we are getting it S15 equals to 465. So the sum of the 15 terms in the given AP is 465. Let's see another example. Find the sum of first 24 terms of an AP whose nth term is given by an equals to 3 plus 2n. Friends, here only the nth term is given. We don't know what is a1, a2, a3. We don't know what is common difference. We know only the n, that's 24 terms for which we need to find out the sum, and the general term which is given as an equals to 3 plus 2n. Let's go for solving it. Given an equals to 3 plus 2n, so a1 equals to 3 plus 2 into 1, which is 3 plus 2 equals to 5. Likewise a2 equals to 7, a3 equals to 9. So we got a equals to 5, d equals to 7 minus 5, 2, and the AP is 5, 7, 9 and so on. Since we got a and d and already n is given, we can find the sum of nth terms. The sum of n terms is given by the formula Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. So the sum of the first 24 terms is S24, which is equal to 24 by 2 whole into 2 into 5 plus 24 minus 1 whole into 2. On solving we get it 672. Hence the sum of 24 terms is 672. Now it is a problem based on finding some of the first m terms when some of first p terms and some first q terms are given. Let's see through an example. If sum of the first 4 terms of an AP is 40 and that of first 14 terms is 280, find the sum of first n terms. Let the first term of the given AP be A and the common difference is D. So it is given S4 is 40 and S14 is 280. Now we know that Sn equals to n by 2 plus 2a plus n minus 1 into d. So S4 is 4 by 2 plus 2a plus 4 minus 1 whole into d. On solving we get 2a plus 3d equals to 20. Let this be the first equation. Likewise, S14 is 2a plus 13d equals to 40. Let this be the second equation. On subtracting equation 1 from equation 2, we get 10d equals to 20 or d equals to 2. Since we got d, putting the value of d in any one of the equation, we can find out a. Putting the value of d in equation 1, we get 2a plus 6 equals to 20 or a equals to 7. So Sn equals to n by 2 whole into 2a plus n minus 1 whole into d, which is by putting the values of a and d, we are getting Sn equals to n square plus 6n. Hence, the sum of the first n terms of the given AP series is n square plus 6n. Now, let's find the problem based on finding nth terms when sum of the first n terms is given. It says if Sn and Sn minus 1 are the sum of the first n and n minus 1 terms of an AP, then the nth term an is given by an equals to Sn minus 1. Let's understand it through an example. If Sn, the sum of the first n terms of an AP given by Sn equals to 3n square minus 1, find nth term and also find the AP. Let's go for solving it. Given that Sn equals to 3n square minus 1, on replacing n by n minus 1, we get as n minus 1 equals to 3 into n minus 1 whole square minus 1, which is equal to 3n square minus 6n plus 2. Now, Sn minus n minus 1 is 3n square minus 1 minus 3n square minus 6n plus 2. That means an equals to 6n minus 3. Now, a1 is 6 into 1 minus 3, which is equal to 3. Likewise, a2 equals to 9, a3 equals to 15, a4 equals to 21, and so on. So, the nth term of the AP is given by an equals to 6n minus 3, and the AP is 3, 9, 15, 21, and so on. Let's learn about arithmetic mean. What is arithmetic mean? It says if A, B, and C are in AP, then B is known as the arithmetic mean of A and C. That means since A, B, C are in AP, B minus A equals to C minus B, or twice of B equals to A plus C, or B equals to A plus C whole divided by 2. So arithmetic mean or AM of A and C is represented as A plus C whole divided by 2. Let's see an example. The sum of the three numbers in an AP is minus 3 and their product is 8. Find the numbers. Let the numbers are A minus D, A and A plus D. So as per the given question, A minus D plus A plus D equals to minus 3. Let this be the first equation, and A minus D into A plus D equals to 8. Let this be the second equation. So from equation 1 we get A minus D plus A plus D equals to minus 3, or 3A equals to minus 3, or A equals to minus 1. So putting the value of A in equation 2, we get a minus d into a plus d equals to 8, or minus 1 minus d into minus 1 into minus 1 plus d equals to 8, or on solving we get d square minus 1 equals to 8, or d square equals to 9, or d equals to 3, or d equals to minus 3. For d equals to minus 3, the numbers in AP are minus 2, minus 1, minus 4, and for d equals to 3, the number in AP are 2, minus 1, and minus 4. Let's see another example. If the sum of the first p terms of an AP is q, and sum of the first q terms of that AP is p, find the sum of first p plus q terms. See friends, here we don't know anything about the AP series. We don't know what is the first term. We don't know what is the common difference. Only sum of first p terms and sum of first q terms is given, and we have to find out the sum of the first p plus q terms. Let's go for solving it. Let a be the first number and d be the common difference of the AP. We know that the sum of the n terms in an AP is given by Sn equals to n by 2 whole into 2a plus n minus 1 into d. So using this formula, we can find out what is the sum of p terms and what is the sum of q terms. So sum of p terms, Sp equals to p by 2 whole into 2a plus p minus 1 whole into d, and this is equals to q. Let this is equation 1. And sum of q terms, Sq equals to q by 2 whole into 2a plus q minus 1 whole into d, and this is equals to p. Let this is equation 2. So equation 1 minus equation 2 is q minus p equals to p by 2 whole into 2a plus p minus 1 whole into d minus q by 2 whole into 2a plus q minus 1 whole into d, or q by q minus p equals to pa plus pd into p minus 1 whole divided by 2 minus qa plus qd into q minus 1 whole divided by 2. Multiplying minus 1 on left hand side, we get minus 1 into p by p minus q equals to pa plus pd into p minus 1 whole divided by 2 minus qa into qd into q minus 1 whole divided by 2, or on solving it we get 2a plus d into p plus q minus 1 equals to minus 2. Let this is equation 3. Now the sum of p plus q terms in an AP can be written as Sp plus q equals to p plus q by 2 plus 2a plus p plus q minus 1 whole into d. Now putting the value of 2a plus p plus q minus 1 whole into d, from equation 3 we get Sp plus q equals to p plus q whole divided by 2 whole into minus 2, or p plus q whole into minus 1, which is equal to minus p plus q. So the sum of p plus q terms of the given AP series is minus p plus q. Let's see another example. A man arranges to pay off a debt of rupees 3,600 by 40 annual installments which are in AP. When 30 of the installments are paid, he died, leaving 1/3 of the debt unpaid. Find the value of 8th installment. Let's go for solving it. Given that the installments are in AP, so we can write the installments as A plus D, A plus 2D, and so on. And the total number of installments is 40, and total debt availed by the person is 3,600. So you can write S40 equals to 3,600. Now we know that the sum of n terms in an AP is Sn equals to n by 2 whole into 2a plus n minus 1 whole into d. So S40 equals to 40 by 2 whole into 2a plus 40 minus 1 whole into d. That is equal to 3600. On solving it, we get 2a plus 39d equals to 180. Let this is equation 1. Now, when 30 of the installments were paid, one third of the debt will remain unpaid. That means by the time the party or the borrower has already paid 2/3 of the debt, so we can write S30 or sum of 30 installments is 3600 into 2 by 3, which is equal to 2400. Now, sum of 30 installments or S30 equals to 30 by 2 into 2a plus 30 minus 1 whole into d, that is equal to 2400, or on solving it we get 2a plus 29d equals to 160. Let this is equation 2. On subtracting equation 2 from equation 1, we get 10d equals to 20 or d equals to 2. Now, putting the value of d in any one of the equation 1 or equation 2, we can find out the value of a. Right? Putting the value of equation d in equation 1, we get 2a plus 78 equals to 180 or a equals to 51. We know nth term an is denoted as a plus n minus 1 whole into d. We have to find out the 8th installment, that means a8. So a8 is 51 plus 8 minus 1 whole into 2, or a8 equals to 65. So the value of the 8th installment is rupees 65. Friends, here we saw a few examples. The more examples you do, the more such kind of questions you do, the easier it becomes and the more you like it. So friends, do practice more and more such questions, more and more such examples. And in case of any difficulty, do share your questions or doubts with me. It will be a pleasure for me to help you out in solving your doubts or queries. So this much for today's class. Thank you.